Hi, good morning. How are you all? Doing well? How are you, Brendan? Kurosai. Okay, Shikail, I hope you are able to understand what I'm trying to teach you. And I'm trying to explain to you, and I hope if you have any doubt, please let me know so that I can respond to you and try to help you out. So, in the previous uh, I hope maths is easy to you now. Okay, you can be able to solve at least to that extent which I have taught you. And when you're doing any sums in mathematics, cross check twice, thrice. Only then you'll be able to be very careful. A minute mistake may result in a huge loss of marks. Okay, so now in the previous section, classes, you have learned how to represent irrational numbers on a number line, right? Now today we will try to find out how to the decimal representation of rational numbers as well as irrational numbers. When you say decimal representation, what do you mean by decimal representation? A decimal representation is a representation where you have a whole number and its trailing numbers, so which are obviously very minute compared to the whole number. So that minute number beyond the whole number is being represented by, is separated from the whole number by a dot. That if I say 10.1 or 10.01 or 10.02 whatsoever, let me take 10.1. When I say 10.1, 10 is a whole number, that's a big number. To that is a trailing number 0.1. 0.1 is 1 by 10. 1 by 10th of it is just added to it. So that is a decimal digit, which is all the digits that lie beyond the decimal point are called decimal numbers. Okay, they are the fraction. That is a small fraction of the whole number. So the whole thing 10.1 is a decimal representation. Okay, so now let us try to understand how do we represent rational numbers in the decimal format. So just hold on, I'll tell you how. Now let us consider three fractions, that is three rational numbers, 10 by 3, 7 by 8 and 1 by 7. These are three rational numbers. Now let us try to find out their decimal representation. How do we represent it in decimal way? So that means 10 by 3 means 10 is divided by 3. Right? Am I right? So 3 will go 3, 3s are 9. Remainder is 1. I put a dot, add a 0 here. 3, 3s are 9. Again a remainder 1, 0. 3, 3s are 9. 1. I add a 0, 3. 3, 3s are 9 and 1, and this goes on like this, and this 3 will keep on recurring. It is not at all terminating, right? It's no termination, because every time I divide 10 by 3, I get the remainder as 1. So this is a non-terminating. This sort of numbers are called as non-terminating numbers. They are not terminating. There is no end for it. You get 3, 3, 3, 3, and this is represented when you have a repetition of the same numbers. When you have the repetition of the same numbers, you can just write the same number, and on the top of it you can put a bar. Okay, even if you put a whole bar on the whole thing is also okay, because 33, 33, 33 taking 2, it's keeping on repeating, right? So this bar represent recurring. The bar on the top in mathematics on a number or a decimal number, above a decimal number, it indicates that it is recurring. Now let us take the second example of 7 by 8. Okay, I have taken 7 divided by 8. It does not go. I say 0.08 are 64, right? So I am left with how much? 8 is 6. I am 6. Add a 0. Okay, 8 sevens are 56. So I am left with 4. I add a 0. 8 fives are 40. So 0. I am left with, this has terminated here. That is there is no continuation of numbers because I've already got as remainder as 0. So this is non-terminating and recurring because the same digit is recurring. This sort of thing is called terminating. Okay, now let us see the third part. 1 7 0 0 7 ones are 7. I'm left with remainder 3. Add a 0. 7 fours are 28. I get 2. Add a 0. Right? 7 twos are 14. I get it as 6. I add a 0. Right? I add a 0 to it.